Hi everyone, this is Sampath Kumar. In this video, we are going to discuss about KPCL previous year question papers. So try to go through the questions. First question, find the expression for the work done. Find the expression for the work done, which is very important, sir. So here the question is, they asked you about only work done. Work done. So you already know, sir, power is nothing but power is equals to work done divided by time, sir. Power equal to work done divided by time, sir. So you already know, sir, voltage V equal to dW upon dQ, current I equal to dQ upon dt, dQ upon dt, power P equal to dW upon dt. So out of these three relations, which relation is going to match? Try to understand. Find the expression for work done. So from here we can say that work done is equals to voltage into charge, sir. From here we can say that work done is equals to voltage into charge, sir. Voltage into charge, which is nothing but answer will be B, sir. So even sometimes they may ask you what is the current? Current is nothing but flow of charges, sir. Charge divided by time. So power is nothing but work done by time. How you will get power? Power is nothing but it is a product of voltage and current. You already know, sir. Voltage is nothing but dW by dQ, sir. Current is nothing but dQ upon dt, sir. So whenever charges get cancelled, power is equals to work done upon time. Power equal to work done upon time. So even sometimes you may come across this one also. Work done is equals to, we can say that power into time over here, but there is no option, sir. So that is the reason why I am going for option B. So sometimes they may ask you units also. Units also important here. Here voltage is nothing but work done units are joules, by charge units are coulombs. Here current units are coulomb per second. Here power units are joules per second. Why? Because work done is measured in terms of joules, sir. This is about first question. So try to go through the second question, sir. Resistance offered by the material in increasing order. They are asking resistance offered by the material in increasing order. Resistance is more, which resistance you need to be increasing, ascending order you need to write. Means first we need to understand highest conductivity. Conductivity is highest for silver, sir. After that copper, sir. After that gold, sir. Least one is aluminum. You already know. Means conductivity is low. Conductivity is low, which is nothing but resistance will be high, which is nothing but resistivity is high. We can say that resistance also high. Why? Because you already know, sir, conductivity is equal to reciprocal of specific resistivity, which means that which of the following has a highest resistance? We need to write in increasing order. Resistance is lowest for silver, copper, gold and aluminum. Aluminum will be the highest resistance. We need to write in increasing order. So silver, copper, after gold, after that aluminum. So option A will be answer, sir. Option A will be answer. So this is the most important question, sir. Sometimes they may ask you which of the following has a highest conductivity? Highest conductivity for silver. Highest conductivity for silver, sir. Try to go to the next question, sir. Which of the following resistor having the which temperature quotient? Means they are asking negative temperature quotient. Means they are asking which of the following is having negative temperature quotient. Sir, the negative temperature and positive temperature quotient you need to understand, sir. Positive temperature quotient is for sensistor, sir. Sensistor. Sensistor having positive temperature quotient, sir, whereas negative temperature quotient for thermistor, sir. Thermistor is having the negative temperature quotient. What is mean by negative temperature quotient? You already know, sir. Whenever temperature increases, resistance going to decrease. What about positive, sir? Temperature increases, resistance is going to increases. That is called as a positive. When temperature increases, resistance decreases. This is called as a negative temperature quotient. These are temperature quotient which are very important. Sensistor is having positive, thermistor is having negative temperature quotient. So try to go through the next question, sir. Simple question here. Simple question. In this question, here, so first try to understand equivalent capacitance is given. Here through capacitance 1 3 micro, 6 micro which are connected in series. What is the equivalent capacitance when 3 and 6 are connected in series? 3 into 6 divided by 3 plus 6. Nothing but 18 divided by 9 which is equals to 2 farad. So here 1 2 farad is there, 1 more capacitor is there. This equivalent they given as 5 microfarad, 5 microfarad. You already know, sir, whenever capacitors are connected in parallel, they are going to add it. So C plus 2 microfarad is equals to total equivalent 5 microfarad. From here we can say that capacitance equals to 5 minus 2 which is equals to 3 microfarad. Which is equals to 3 microfarad. So option A will be the correct answer. Option A will be the correct answer. Next question, sir. Dielectric constant of air. What is the dielectric constant of air, sir? So dielectric constant of air is equals to 1, sir. Even vacuum also equals to 1, sir. Even vacuum is also equal to 1, sir. Highest dielectric constant is for water, sir. Approximately 80, sir. So you need to understand, instead of water, you need to understand about paper as well as mica. Paper as well as mica. Why? Because these are the most commonly used, sir. Paper is for 3.5, sir, dielectric constant. When it comes to mica, so what will be the mica, sir? It will be 5 to 7, sir. Mica will be 5 to 7. These are the dielectric constant of different materials. So here they asked you about what is the air dielectric T. So air dielectric constant is 1. Try to go through the next question. If the charge is given, capacitance value is given, find the energy stored by the capacitor. Sir, what is the formula? Energy stored by capacitor is equals to, energy stored by capacitor is equals to, energy stored by capacitor is equals to half C into V square. Energy should be expressed in terms of joules. So first try to understand what are the values are given. Here capacitance value is given and charge is given. So charge Q equal to 0.075 and capacitance value is 340.9 microfarad. So in order to substitute in this formula, definitely you know the value of V. First try to find out the value of V from this expression. Charge Q equal to C into V, sir. From here V can be calculated as Q divided by C. So Q is nothing but 0.075 divided by 340.9 into 10 to the power of minus 6, sir. So which is approximately equals to, voltage is equals to approximately, this value you will get around 220 volts, sir. 220 volts. Now try to substitute over here. Half, already you know the C value, 340.9 into 10 to the power of minus 6 into V square, 220 whole square. So you will get around 8.25 joules, sir. You will get around 8.25 joules. This is the formula you can use for in order to find out the energy stored by capacitor. Sometimes they may ask you what is the energy stored by inductor also. Energy stored by inductor, you need to use the formula half Li square. Sometimes they won't give you directly inductance. At that time you need to use the formula flux linkages I equal to L into I equal to N into phi. This is the formula you can use it, sir. Whenever you need to find out the energy stored in case of inductance. Next one, sir. With a usual notation, find the electric field strength or electric field intensity. Electric field intensity we discussed in case of Ohm's law. J equal to sigma into E, sir. This is nothing but electric field intensity. Electric field intensity equal to V divided by D, sir, which is measured in terms of volt per meter, sir. Which is measured in terms of volt per meter, V divided by V. Electric field intensity is equals to V divided by D, sir. Next one. This is a simple network question, sir. Try to go through it. If the 8 ohm resistance is short, whatever the 8 ohm resistance is given, this is short. Short circuit is 0. Whenever short circuited with parallel with any combination, this total resistance will be 0. So only one resistance which is present is, one is 4 ohms, sir, Another one is 10 volts, sir. Another one is 10 volts, sir. So what they are asking, find the power consumed across 4 ohm resistor. So in order to find out power, you can use any formula, sir. First, you can find the current. Once after current, you can find the value of power. That is also one method. Or you can directly apply power. You know the value of V, you know the value of R. Power equal to V square divided by R. V square by R is nothing but 10 square divided by 4, nothing but 100 by 4, which is equals to 25 watts. 25 watts. So answer C. Even the same question you can use in different way also. First I am finding the current, sir. Current I is equals to 10 divided by 4. Power equal to I square. Across, we need to find out across a 4 ohm resistor. We need to find out the power across a 4 ohm resistor. Power consumed, nothing but 100 divided by 16 into 4. 4 ones are 4 fours are 100 by 4. You also get the same answer, 25 watts. Even you can do that method also. Either of the method you can follow, sir. Next one. A 5 ohm become inoperative due to open circuited. Means 5 ohm resistor is not there. This 5 ohm resistor is eliminated. It is eliminated. It is open circuited. Find the power consumed in a 3 ohm resistor. Find the power consumed in 3 ohm resistor. This method also you can do either of the ways, sir. First try to find out the values, sir. Here 12 volts. 12 volts. Here 4 ohm resistance is there given. 5 ohm resistor is open circuited. This is 3 ohms, sir. Here 6 ohms, sir. Here 6, sir. Sir, whenever, in order to find out the equivalent resistance, these two values are connected in parallel, the parallel combination will be 3 into 6 by 3 plus 6. Nothing but 18 divided by 9, which is equals to 2 ohm. Which is equals to 2 ohm. So here 4 ohms, sir. Here 2 ohms, sir. Here 12 volts, sir. So even you can directly find the voltage across over here. What is the voltage across here? 12 into 2 divided by 6, 6 ones are 6 twos are. So voltage will be 4 volts, sir. The same 4 volts which is applied across 3 ohm and 6 ohm, 3 ohm and 6 ohm. So power equal to 16 divided by 3. Approximately 16 divided by 3, you will get 5.33. This is the one method of solving. Just I find out the voltage across this set. So voltage across 2 ohm is nothing but this set. This is the voltage. Why? Because these two are connected in parallel. Voltage is same in parallel. So V you already know, R you know. That's why I use the formula power equal to V square by R. This is the one method of doing. Another method of doing the same question here is, so first try to find out the current over here. First try to find out the current. What is the current, sir? Current I equal to V by R, nothing but 12 by 6, sir, which is equals to 2 ampere. Now, I need to divide this 2 ampere. How this 2 ampere is going? So, this is 3 ohm, this is 6 ohm, here 2 ampere is coming, here 4 ohm, sir. Now, I need to find out what is the current flowing through 3 ohm. First, try to find it out. What is the current, sir? You need to apply the current division. In order to apply the current division, total current is 2 ampere. I need to find out the current through 3. You need to apply opposite resistance divided by sum of the resistance 9. 3 2s are, 3 3s are, current I equal to 4 divided by 3. The current which is flowing here is 4 by 3. I need to find out power. Power equal to I square times R. I square means 16 by 9 into R. 3 1s are, 3 3s are, nothing but 16 by 3. Again you will get the same answer as 5.33. 5.33. So you can do in both the ways, sir. Which method is you follow? You can follow that method. Next, try to go through the next question, sir. In the figure shown in below, what is the dependent source? So whatever the dependent source is there, you need to identify name of the dependent source. So this is the dependent source, sir. Basically, dependent sources are represented by diamond shape. There are total 4 dependent sources are there. So out of 4 dependent, we need to identify. First, try to identify, sir, inside the diamond shape, if current source is here, arrow symbol is there, we can easily say that is the current source. For example, inside the diamond shape, if plus minus is there, then we can say that is a voltage source. So we can easily eliminate the two options. This is not the voltage source. This is not the voltage source. Why? Because inside is arrow is there. It is a current source. Easily we can eliminate 2 options, sir. Now we need to find out of 2 options what source it is. Sir, here dependent is current element, sir, 6 into I naught. That's why it is called as a current dependent current source. Dependent also other name is called as a controlled. Dependent also called as a current controlled. So current controlled current source. So option will be D, sir, current controlled current source. Next, try to go through the next question, sir. Find the resistance equivalent between the terminals A and B. Terminals A and B. So here this is B. Here short circuited, nothing is there. Here also B, sir. Here also short circuited. Here also B, sir. Here A, sir. Here there is no element is connected. That's why this one is also A, sir. But here one more point, one more node is there. That's why I am naming other name which is C. So we need to find out the equivalent resistance between A and B, and one more node is there, C. So these are the basic nodes, sir. Now we need to connect what are the resistance connected between them. So A and C, 5 ohm is there. Between A and C, 5 ohm is connected. Between A and C, 20 ohm is connected. Again A and C, 20 ohm is connected, sir. Next, again A and B, 6 ohm is connected. A and B, 6 ohm is connected. Next, B and C, 2 ohm is connected. B and C, 2 ohm is connected. Here 2 ohm is connected. Now try to find out the equivalent resistance between A and B. So these two are connected in parallel. Whenever these two are connected in parallel, you will get 20 into 5 divided by 20 plus 5, sir, which is nothing but 25. 5 ones are 5 5s are, which is nothing but 20 by 5 is nothing but 4. So this equivalent value will be is equals to 4. Now try to draw the circuit again. This is 6 ohms, sir. Here it is 4 ohms, sir. Here it is 2 ohms, sir. We need to find out equivalent resistance. You already know, sir, 4 and 2 are series. 6 parallel. Whenever both equal resistance are connected in parallel, R parallel, you will get equivalent resistance as R by 2. So 6 parallel will be equal to 6 by 2, which is equals to 3 ohms, sir. Which is equals to 3 ohms, sir. So option C will be the correct answer. Option C will be the correct answer. Now try to go through the next question. Find the Thevenin's equivalent resistance between terminal A and B. So whenever finding the equivalent resistance between A and B, you need to short circuit this voltage source, sir. Whenever voltage source is short circuited, try to find out the equivalent resistance. This is 5 ohms, sir. 5 ohms, sir. A and B. Here 20 ohms, sir. 20 ohm. So A and B, these two are connected in parallel. So 20 into 5 by 20 plus 5, 25. 5 ones are 5 5s are, which is equals to 4 ohm. Which is equals to 4 ohms, sir. Try to go through the next question, sir. This is which is related to measurement question. So in case of measurements, wattmeter method, there is only one formula which is used in order to find out the power factor, which is nothing but phi equal to cos phi. Cos phi equal to cos of tan inverse of root 3 into W1 minus W2 divided by W1 plus W2. So this is a formula you need to use while in order to know the power factor. So wattmeters were given. W1 is given as 5.3 and W2 is given as minus 1.7. Just try to substitute over here. Cos of tan inverse of root 3 into W1 minus W2. 5, 6, 7. Means plus 7 divided by W1 plus W2. So how much you will get, sir? W1 plus W2, if you do that, so you will get around 3.6, sir. This will be 3.6, sir. So after that, try to find out the value of this value. This value approximately you will get as 73.42, sir. 73.42, sir. So when you apply cos value to this one, you will get around 0.282. 0.282. This is the value you will get, sir, after calculations. This is a simple smallest question, sir. What they ask, phi is the angle between voltage and current. Expression for the power factor. Power factor is nothing but cos of angle between the voltage and current only, na? So nothing but cos phi. Power factor is nothing but cos phi. Next, expression for the power factor. Power factor, this is from the power triangle they are asking. So this is the active power, sir. This is reactive power, sir. This is the upper end power, sir. So active power which is measured in terms of watts. Reactive power which is measured in terms of watts. Upper end power which is measured in terms of volt ampere. From here, power factor cos phi is nothing but active power divided by upper end power, which is nothing but P divided by S. Active power by upper end power. So option A, sir. Next question in the similar format, find the expression for power factor. But here impedance triangle is given. So from the impedance triangle we can say that this is a resistance, this is a reactance, this is the impedance. So from here cos phi equal to resistance divided by magnitude of impedance, R divided by Z, which will give the power factor of the circuit. Next, try to go through the next question, sir, which is related to power electronics question. A thyristor is triggered by dV by dt equal to 200 volts per microsecond. Forward breakover voltage is, find the forward, if the forward breakover current is given as 5 milliampere, find the diffusion capacitance. They are asking diffusion capacitance, sir. So current is given, voltage is given, capacitor. You know the formula current I equal to C into dV by dt. So you need to find out the capacitance. Capacitance equal to current divided by dV by dt. So current is 5 milliampere. 5 into 10 to the power of minus 3 divided by dV by dt is nothing but 200 volt divided by micro 10 to the power of minus 6 second. So while applying, you need to substitute all the values, sir. Then only that will be correct. So after doing that, you will get around 5 by 200, 5 by 200, sir. If 10 power minus 6 going to numerator, it will be 10 to the power of minus 9, sir. 10 to the power of minus 9. 5 ones are 540s are, you will get around nothing but you will get around 25 picofarad, sir. You will get around 25. 1 by 4. 1 by 4 is nothing but 0.25, sir. If you substitute that, 1 by 40 is there, so you will get 0.025, which is nothing but 10 to the power of 12 minus 12 pico. So you need to understand the value of terminology over here. Pico and micro and nano. You already know, sir. 1 pico is equals to 10 to the power of minus 12. Nano is nothing but 10 to the power of minus 9. Micro is nothing but 10 to the power of minus 6. Milli is nothing but 10 to the power of minus 3. So this is a micro, sir. Next one, sir. Simple question which is based on thyristor. A thyristor is negatively biased. Thyristor is negatively biased. Negatively biased means here P1, N1, P2 and N2. Here junction J1, J2, J3. Negatively biased means anode, cathode, here gate. Negatively biased means anode is connected to negative, cathode is connected to positive. If you connect that, junction J1 and J3 will be reverse bias, only J2 will become forward bias. So outer junctions are negatively nothing but it is reverse biased, sir. Negatively nothing but reverse biased. Inner junction is forward biased. So answer will be C, sir. Answer will be C. Try to go through the next question, sir. A single phase diode rectifier supplies the power to highly inductive load. The load current is ripple free current. The waveform of the AC supply current will be. Why? Because in case of a single phase full wave diode rectifier, these are the full wave diode rectifiers, sir. These are the full wave diode rectifiers, sir. This is the load. This is the your source current you are going to apply over here. Here D1, D2, D3 and D4. Diode rectifier, sir, here diode D1, D2 is positive from 0 to pi. After that D3, D4 will come. Whenever D1, D2 come, your source current will be in this format. But whenever D3, D4 is getting on, the current will be flowing in this format. It will be reverse format. Means half of the cycle it will be positive, remaining half of the cycle it will be negative, which is equals to square waveform shape. Which is equal to square waveform shape. Next one, a simple question, sir, which is based on transistors, nothing but which is related to basic electronics. Bipolar junction transistor is on. Bipolar junction transistor is on. When bipolar junction is going to be on? Whenever, when we can say that BJT will be on state, off state, amplifier state. So BJT will be on state when we can say that BJT will be on. So here emitter base junction, also collector base junction, sir. Both are forward bias. Both are forward bias. It will be saturation. It will be treated as a on switch. Both are reverse bias. It will be treated as a cutoff, sir. It will be treated as a off switch. Emitter base junction is forward bias. Collector base junction is reverse bias. It is operated in active region, sir. It will be treated as a amplifier. So based on that you can match, sir. Based on that you can match. So bipolar junction transistor is on state when it will become on state. So try to match that one. Next one, sir. Thyristor circuits that directly convert polyphase AC voltage at one frequency to AC voltage at one frequency to another frequency. Means here frequency is changing, sir. Where your frequency is going to change? In case of cycloconverter, frequency is going to change. That's why it will be cycloconverter. And they are varying the AC voltage, sir. AC to AC converters are two types. One is AC voltage regulator. Another one is cycloconverter. In case of cycloconverter, frequency variable. But whereas in case of AC voltage regulator, frequency is constant. Frequency is constant. So these two are very, very important, sir. Now try to go through the next question, sir. Which of the following statements are not true? Not true. They are asking which of the following statements are not true, sir. Try to see here. Track is a 3-terminal. Yes or no? It is a bidirectional. Track is nothing but two SCRs which are connected in anti-parallel fashion. You already know, sir. Here multi-terminal 1, here multi-terminal 2. Another terminal is called as a gate terminal. So that's why they treat it as a 3-terminal device. Bidirectional, yes or no? Current will be flow in this way, current will be flow in this way. Bidirectional. And two SCRs are connected anti-parallel. Yes or no, sir? Here two SCRs are connected anti-parallel. Diac is a 2-terminal device. Yes. It is also bidirectional. Yes or no, sir? Diac is nothing but two diodes are connected in anti-parallel fashion. So it will allow the current in both the ways, sir. So that's why it is also bidirectional, sir. Next one, IGBT is a voltage control device. Yes or no, sir? BJT is a current control device. BJT is a current control device. Whereas MOSFET and IGBT both comes under voltage control devices. MOSFET and IGBT both comes under voltage control device. So power BJT is faster than MOSFET in switching. No, sir. MOSFET is the highest switching frequency. That's why MOSFET is so faster compared to BJT. So answer D will be the wrong answer. Answer D will be the wrong answer. Try to go through the next question, sir. Next question. A ideal single quadrant chopper operating in first quadrant is supplied from the ideal voltage source of battery. Battery voltage is given VDC equal to 220 volts and load voltage is waveform rectangular pulse size duration 1 millisecond. So it is on for 1 millisecond. So this is the on period is given. Total time period is given as 3 milliseconds. So you need to find out the average and RMS value. So in case of buck chopper, what is the average value? V0 equal to D times of VDC, sir. D is nothing but on period by total time period into 220. What about VRMS? VRMS equal to square root of D into VDC, sir. So square root of 1 divided by 3 into 220, sir. So if you do so, you will get around 73.33 comma 127 volts. 73.33 comma 127 volts. So these are related to our power electronics. Next one, sir. Here circuit is not given. I am drawing the circuit, sir, here. Circuit is like this. So circuit, which of the following circuit is thyristor T1, D2, thyristor T3 and D4. So this circuit comes under which of the following? Sir, you already know, sir, here two thyristors are there, two diodes are there. When two thyristor, two diodes, it is a combination of SCR and diodes. Whenever it is a combination of SCR and diode, it comes under single phase half controlled rectifier. Also it is called as a semi-converter. It is also called as a semi-converter, also called as a half control. Semi-converter also called as a half controlled rectifier. Half controlled rectifier. I think this is for the previous one, sir. This is for the previous one diagram. The circuit shown in the below figure is T1, D2, T1, D2, D3 and T4, D4 and T4. Here also you can see, sir, two thyristors are there, two diodes are there. This is a combination of, we can say that our whatever the semi half controlled converter is there, it can be connected in three ways, sir. One is symmetrical configuration, asymmetrical configuration, and after that full wave rectifier with Freewheeling diode. Sir, previous one is whatever I drawn here, this is symmetrical configuration. Why? Because two SCRs are connected at same terminal. But in this case, two SCRs are connected in a single pole. This is called as a asymmetrical configuration. Even one more is also there, sir. This is called as a full wave rectifier with Freewheeling diode, sir. This is full wave rectifier with Freewheeling diode, sir. This is also whenever Freewheeling diode is connected, it is also comes under semi-converter configuration only. So it is a single phase half controlled rectifier, sir. Single phase half controlled rectifier. Next question, sir. In the circuit shown in the devices, the conducting during the positive half cycle. Positive half cycle, who are conducting? Here diagram is missing, sir. Try to draw the diagram here. Thyristor T1. This is our half control rectifier. I am drawing the half control rectifier over here. During the positive half cycle means 0 to pi. They are asking. So I am considering this is thyristor T1, here D2, thyristor T1, D2, here thyristor T3, and I am considering it as a D4, sir. So during the positive half cycle, who are going to conduct? Sir, during the positive half cycle, you are triggering at the thyristor T1, sir. Thyristor T1 triggering, so the next will be D2 will be turned on. So T1, D2. This is the positive half cycle. So T1, D2 going to be conducted. Next one, last question, sir. Here, the largest power gain is obtained in case of. So you already know, sir. This is a common base, common emitter, and common collector configuration. So common base, current gain, voltage gain, power gain. So you already know, sir, current gain is whatever the voltage gain is approximately less than 1, sir. Here voltage gain is high, sir. Here voltage gain is medium. So here common base current gain is less, sir. Here common current gain is medium. Here current gain is high. So what about they are asking the power gain? So power gain, here both voltage and currents are medium. So power gain will be highest, sir. For which means common emitter configuration, highest. So after that moderate will be common collector, sir. It is a low to moderate for a common base configuration. This is related to common emitter, common base and common collector configuration. So these are the questions which were previously asked in Kpcl JEE examination. Thank you everyone. Wish you all the best.